beneath the world's largest desert, something doesn't add up. Satellites see hidden rivers. Scientists find cities where no water should exist. Human remains appear in places no one was supposed to live. And every year, new data rewrites what we thought was impossible. If an entire civilization vanished under the sand, why are its traces still surfacing now? And what else is buried that we haven't found yet? The desert that keeps records. The Sahara is often described as an empty expanse, but its surface is varied. Large dune fields exist, yet much of the region is gravel, plain, exposed bedrock, salt flats, and volcanic plateaus. Mountain ranges such as the Tibesti and the Ahagar break the horizon in the central Sahara. Wind moves sand from place to place, leaving some areas scoured and others buried. When sand shifts, older ground can reappear, including compacted lake beds and stone pavements that hold artifacts in place. Researchers working on North African paleoclimate describe a long wet phase in the early and middle Holocene, commonly referred to as the African humid period. Monsoon rains reached farther north than they do today. Shallow lakes filled depressions across what is now desert, and river systems ran in valleys that are now dry most years. When rainfall weakened, shorelines retreated and basins dried, leaving lake sediments and beach ridges behind. These changes are traced through sediment cores, shoreline mapping, and dated sequences of wet and dry layers, as well as through comparisons with regional records from lakes farther south. Archaeological evidence from the central Sahara is often tied to those former water sources. One documented example is Gobero, in Niger's Tenere region, where dunes sit within a former lake basin. The site was reported in October 2000 by photographer Mike Hetwer during a field expedition led by Paul Sereno. Excavations and later publications describe burials and habitation remains linked to a freshwater lake that once sat in the basin. A peer-reviewed study described early Holocene occupants dated to roughly 7,700 to 6,200 BCE, followed by later burials and artifacts indicating repeated use separated by climatic shifts. In southwest Libya, Takakori rock shelter provides a different record because it preserves layered deposits under an overhang. Radiocarbon sequences have been modeled to describe phases that include late Akakos hunter-gatherers and later pastoral periods. Published work has placed occupation phases across the early and mid-Holocene, with transitions that align with broader environmental change in the region. Reports on the burial area note a repeated pattern at the site. The documented burials are predominantly women and children, placed close to the rock wall, with limited grave goods in many cases. Rock art sites provide another archive of what was present when the Sahara had more water. The Tassili N'Ajjer Plateau in Algeria contains thousands of paintings and engravings that have been studied since the 19th century. Sketches by French legionnaires in the 1930s, including Lieutenant Charles Brennan's, helped bring wider attention to the paintings. The French archaeologist Henri Lotte led major recording campaigns beginning in 1956, 1957, and returned in later years. The images include cattle, wild animals, and human figures in activities that imply water and vegetation. The plateau today is an arid landscape of sandstone towers and sheltered gullies. Below the surface, the Sahara contains large bodies of groundwater that hydrology describes as fossil water, stored in deep rock from older climatic periods. The Nubian sandstone aquifer system spans parts of Egypt, Libya, Sudan, and Chad. Scientific publications treat it as a major water resource in a hyper-arid region, and technical cooperation projects have been organized to study and manage it across national borders. The aquifer's extent is mapped through drilling and geophysics, while water age and flow can be investigated with isotopes and other chemical tracers. Libya's Great Man-Made River is a modern example of extracting and moving fossil groundwater. The project's history is tied to the discovery of large quantities of potable water during oil exploration in the 1950s and later planning in the 1960s. Construction began in 1984. A first phase was inaugurated on 28 August 1991, and a later phase, supplying Tripoli, was inaugurated on 1 September 1996. The system uses desert well fields, long pipelines, and coastal distribution networks. Operation depends on pumping capacity, pipe integrity, and regular repair of components exposed to heat, sand abrasion, and corrosion over long distances. Remote sensing expanded what could be identified without excavation. In November 1981, the Space Shuttle Columbia carried shuttle imaging radar, known as SIRA, during an Earth observation experiment. Researchers analyzing the radar data reported evidence of buried river channels in the Sahara, and NASA later summarized the result as the first indication of ancient river channels beneath the sands of the Sahara. Under certain conditions, radar can detect contrasts between buried channels and surrounding sediments, allowing old drainage patterns to be traced across areas where surface clues are faint. Ground evidence from historical periods shows that desert societies also engineered access to groundwater in ways that left durable remains. In the Fezzan region of southwest Libya, the Garamantes developed towns, forts, and agricultural settlements centered on the Wadi al-Ajal. Archaeological research describes a network of underground channels and vertical shafts, often referred to as foggara, used to tap groundwater and move it toward fields. Classical authors mentioned the Garamantes, and excavations have documented cemeteries, defensive structures, and urban areas around the ancient center known as Garama. These records do not sit in one place or at one depth, and they do not come from one method. Burials at former lake shores represent direct human presence at the surface. Rock art preserves scenes made when water and vegetation supported animals and herding. Aquifers represent long-stored water in deep rock that can be sampled and pumped. Radar and satellite imagery identify buried channels and basin structures that are not obvious from ground level. Modern pipelines and older tunnel systems show separate ways of relying on subsurface water in a region where surface water is rare. Fieldwork in the Sahara is shaped by access, permits, and the physical scale of the terrain. Many discoveries begin with reconnaissance, satellite imagery, or a single exposed object noticed after a season of wind. Excavation tends to be targeted, with small trenches, test pits, and sampling designed to answer specific questions about dates, diet, or environment. The resulting record is precise in some places and sparse in others, with gaps that reflect both ancient change and modern limits on what can be examined on the ground. How the desert covers and uncovers its own sites. Sand movement in the Sahara follows measurable patterns driven by prevailing winds, surface roughness, and seasonal pressure systems. In many regions, dominant winds from the northeast and east transport fine and medium-grained sand across open plains and into dune fields. Satellite observations from the 1970s onward, including Landsat imagery, have documented migration rates for certain dune systems in Mauritania, Niger, and southern Algeria. Some Barchan dunes have been recorded moving several meters per year under stable wind conditions, while larger compound dunes shift more slowly. Where sand accumulates, older land surfaces become buried. These buried surfaces are often preserved beneath relatively stable dune layers. In areas where vegetation once existed, root structures and soil horizons can remain intact below the sand. Geoarchaeological studies have documented such layers in parts of northern Mali and western Chad, where former grasslands are sealed beneath aeolian deposits. Radiocarbon dating of organic material from these buried soils has been used to establish periods of surface stability and occupation. Deflation represents the opposite process. When strong winds remove loose sand and silt, compacted layers are exposed. These deflation surfaces can reveal stone tools, hearthstones, and fragments of pottery that were previously covered. Researchers working in the Caucasus Mountains of Libya have described deflation pavements where lithic scatters appear gradually over several years. The material does not emerge all at once. Instead, objects become visible as finer particles are removed, leaving heavier stones behind. Former lake basins are especially sensitive to deflation. After drying, fine sediments settle on the basin floor. Over time, these sediments can be lifted and transported as dust. The Baudelaire Depression in northern Chad is a documented example. Studies published in the early 2000s identified it as one of the world's major dust sources, supplying mineral particles to the Atlantic and Amazon basin. The exposed diatomite deposits in the basin originate from ancient lake sediments. Similar, smaller basins across the Sahara show related processes, although on a reduced scale. Erosion also affects rock shelters and cliff faces that contain archaeological material. Thermal expansion, salt crystallization, and occasional rainfall weaken sandstone and limestone surfaces. In Tassili N'Ajjer, conservation reports note gradual flaking and exfoliation of painted surfaces. Rock fragments detach and fall, sometimes covering older deposits. Over long periods, this leads to partial burial of shelter floors and the displacement of artifacts from their original context. Seasonal water flow, although limited, still contributes to redistribution. Wadis that remain dry for most of the year can experience short, intense floods after rare storms. These events transport gravel, sand, and organic debris downstream. In 2010 and 2013, localized flooding in parts of southern Algeria and Niger was recorded in meteorological and hydrological reports. Field teams working in those areas later observed changes in surface artifact distributions along wadi margins. Because of these processes, surface archaeology in the Sahara requires repeated observation. A location surveyed in one year may appear empty in another, or newly exposed material may appear after a period of wind activity. Long-term survey projects account for this variability. The Central Sahara Project, active in Libya from the 1950s to the 1970s, included repeated visits to mapped locations, allowing researchers to compare changes over time. Similar methods were later used by Italian and German teams working in the Tadrat-Akakus region. Remote sensing has become a primary tool for identifying buried or obscured features. Multispectral satellite imagery can distinguish between different sediment types and moisture levels. In some cases, paleochannels appear as linear color variations associated with subsurface moisture retention. Radar systems, including later shuttle missions and satellite-based synthetic aperture radar, have been used to trace subsurface structures beneath shallow sand cover. Publications from NASA and the European Space Agency describe applications of these techniques in eastern Libya and western Egypt. Aerial photography also plays a role, particularly in areas where sand cover is thin. Surveys conducted by French and British teams in the mid-20th century relied on black and white aerial photographs to map ancient field systems and trackways in parts of southern Algeria and Tunisia. These images remain archived and are sometimes compared with modern satellite data to assess changes in surface conditions. Ground verification follows remote identification. When a potential feature is detected, field teams use GPS mapping, test pits, and shallow coring to confirm its nature. Sediment cores provide stratigraphic sequences that show alternating layers of sand, clay, and organic material. In former lake basins near Kufra in southeastern Libya, coring projects in the 1990s produced profiles that linked surface features with deeper lacustrine deposits dated by radiocarbon and optically stimulated luminescence. Visibility also depends on light conditions and viewing angle. Low-angle sunlight in early morning or late afternoon casts shadows that highlight subtle ridges and depressions. Survey manuals for desert archaeology recommend working during these periods when possible. Small stone alignments, hearth circles, and shallow pits are easier to detect under oblique lighting than at midday. Human activity continues to alter surface conditions. Vehicle tracks, construction, and mineral exploration disturb sediment layers and can expose buried material. Oil and gas surveys in parts of Algeria and Libya have occasionally revealed stone structures or fossilized soils during drilling and trenching. Reports from the 1970s and 1980s describe instances where survey crews encountered archaeological material while preparing seismic lines. At the same time, disturbance can damage context. Once objects are removed from their original position, their association with specific layers or features becomes harder to reconstruct. For this reason, many field projects emphasize minimal intervention. Surface mapping and non-invasive techniques are often preferred before excavation is considered. Documentation practices reflect these constraints. Survey reports typically include detailed coordinates, photographs, sediment descriptions, and notes on surface stability. Some teams install reference markers to measure dune movement and sediment accumulation over time. In Niger's Aïr region, long-term monitoring plots established in the 1990s recorded changes in sand thickness and artifact exposure across multiple seasons. Preservation varies across the desert. In some stable gravel plains, artifacts can remain exposed for thousands of years with limited movement. In active dune corridors, material may be buried and re-exposed multiple times. The resulting archaeological record is uneven, shaped by both ancient settlement patterns and ongoing environmental processes. Understanding these processes allows researchers to interpret what is visible and what remains hidden. A cluster of tools on the surface may represent a long-term campsite that has been repeatedly uncovered, or it may reflect the concentration of objects by wind sorting. A blank area may indicate true absence or simply deeper burial. Interpretation depends on combining surface observation, subsurface data, and regional environmental records. Traces of water that no longer flows. Across the Sahara, many valleys that appear dry today were once parts of active drainage systems. These channels are often shallow and wide, with gently sloping sides and compacted beds. In Arabic, many are called wadis, while in geological literature they are referred to as paleochannels when no longer active. Their paths can be traced through subtle surface depressions, gravel alignments, and changes in vegetation density after rare rainfall events. Early documentation of fossil river systems began during colonial-era surveys. In the 1930s and 1940s, French geographers working in Algeria and Niger recorded dry valleys that extended hundreds of kilometers. These records were based on ground observation, aerial photography, and comparisons with active rivers farther south. Later mapping confirmed that many of these valleys connected inland basins with former lakes and wetlands. One of the most studied systems is the Wadi Hawa in northern Sudan. It extends westward from the Nile Valley into what is now desert. Geological and archaeological studies in the late 20th century described it as a former major tributary of the Nile. Sediment analysis and radiocarbon dating indicate that it carried seasonal water during the early and middle Holocene. Along its former course, researchers documented campsites, stone tools, and pottery fragments associated with fishing and pastoral activities. In eastern Libya and western Egypt, satellite imagery revealed networks of buried channels beneath shallow sand cover. These systems are often associated with the Kufra Basin and surrounding plateaus. Radar surveys conducted in the 1980s and 1990s identified linear features interpreted as ancient rivers flowing toward internal basins. Subsequent field verification confirmed the presence of gravel beds and rounded stones consistent with fluvial transport. The Tamanrasset River system, sometimes referred to in geological literature, represents another large-scale drainage network. Reconstructions based on satellite data and sediment cores suggest that it once carried water from the Hoggar Mountains toward the Atlantic coast. Although it is no longer visible as a continuous valley, fragments of its course can be traced through Mauritania and southern Algeria. Marine sediment cores off West Africa contain material linked to this former system, supporting the interpretation of long-distance transport. Lakes formed where rivers terminated in low-lying basins. These paleolakes left behind shoreline ridges, beach gravels, and laminated sediments. In the Chad Basin, Lake Megachad reached its maximum extent around 6,000 years ago, covering an area much larger than the modern lake. Geological surveys and radiocarbon dates from shoreline deposits document this expansion and later contraction. Smaller paleolakes have been identified in Niger, Libya, and Sudan. Lake Yoa in northern Chad provides a continuous sediment record spanning several thousand years. Core samples extracted in the 1990s revealed alternating layers of organic material, dust, and evaporite minerals. These layers reflect changing water levels and climate conditions. Because the lake did not dry completely, it preserves one of the most detailed regional climate archives in the Central Sahara. In southern Libya, the Merzouk Basin contains evidence of former lakes and wetlands. Satellite images show circular and oval features interpreted as dried lake beds. Fieldwork confirmed the presence of clay-rich sediments, freshwater mollusk shells, and plant remains. Radiocarbon dates place many of these deposits within the African humid period. Some basins were reused intermittently as water sources during later, drier phases. Water movement also occurred underground. Recharge during wetter periods filled porous rock layers and sandstone formations. As surface rivers disappeared, groundwater continued to flow slowly through these systems. Springs emerged where geological structures forced water upward. In the Tibesti and Enedi regions, fossil spring deposits have been mapped and dated. These include carbonate crusts and travertine formations formed by mineral-rich water. Some of these springs supported long-term settlement. At Jebel Uweinat, on the borders of Libya Egypt, and Sudan. Archaeological surveys documented rock shelters and open-air sites near former water sources. Pottery, grinding stones, and animal bones indicate repeated occupation. The location's importance appears linked to its access to both surface runoff and groundwater seepage. The identification of paleohydrological features relies on multiple methods. Sedimentology examines grain size, sorting, and mineral composition to distinguish river deposits from wind-blown sand. Geochemistry analyzes isotopes and trace elements to determine water sources and evaporation histories. Geomorphology maps landforms created by flowing water, such as terraces and meanders. Each approach contributes partial information that must be combined. Remote sensing has expanded the scale of observation. Multispectral data highlight moisture-retaining sediments. Radar penetrates shallow sand layers. Digital elevation models reveal low-relief valleys that are difficult to see from ground level. These tools allow researchers to reconstruct drainage networks across thousands of square kilometers without continuous field access. Ground surveys remain necessary to verify interpretations. Teams collect sediment samples, measure stratigraphy, and record associated artifacts. In many cases, paleoriver channels are only a few meters deep, making them vulnerable to erosion and burial. Excavation trenches placed across these features show layered sequences of river gravel, overbank silt, and later wind-blown sand. Archaeological material found near paleochannels often reflects water-dependent activities. Fish bones, shell fragments, and net weights have been recovered at sites in Sudan and Niger. Grinding stones and plant residues suggest processing of wild grasses and cultivated crops in some regions. Herding-related remains, including cattle bones and tethering stones, appear in later phases. Not all channels supported continuous occupation. Some flowed only during brief climatic episodes. Others shifted course repeatedly, leaving abandoned branches. Mapping studies show that many valleys were active for limited periods before drying. This intermittent pattern complicates attempts to link specific sites to specific hydrological phases. Historical records provide limited information about these systems. Classical authors such as Herodotus and Pliny mentioned rivers and oases in North Africa, but their descriptions are often generalized. Medieval Arabic geographers recorded caravan routes and wells rather than river networks. Most detailed reconstructions depend on modern geological data. Water traces continue to influence present-day land use. Modern wells often tap ancient aquifers recharged by former rivers. Oases such as Kufra, Dakhla, and Karga owe their existence to subsurface flow linked to paleo-drainage systems. Agricultural development in these areas depends on managing water that accumulated thousands of years earlier. The distribution of paleorivers and lakes forms a spatial framework for understanding human movement. Travel routes, settlement clusters, and exchange networks often align with former water corridors. However, these alignments are established through cumulative mapping rather than single discoveries. Each newly identified channel or basin adds detail to an incomplete regional picture. The Sahara's dry surface conceals a layered history of flowing water. Riverbeds, lake floors, and spring deposits remain embedded in sediment and rock. Their study depends on patient measurement, repeated survey, and careful comparison across disciplines. The resulting reconstructions remain provisional, adjusted as new data become available. Habitations along vanished shores. Many archaeological sites in the central and eastern Sahara are located on elevated margins of former lakes and wetlands. These locations provided access to water while remaining above seasonal flooding. Shoreline ridges, low terraces, and stabilized dunes often contain concentrations of material that reflect repeated occupation. Their positions can be reconstructed through sediment mapping, shoreline geomorphology, and radiocarbon dating of associated deposits. At Gobero in Niger, habitation areas were identified on slight rises along the edge of an ancient lake basin. Excavations documented hearths, stone tool scatters, animal bones, and clusters of pottery fragments. Stratigraphic analysis showed alternating layers of occupation, debris, and wind-blown sand. These sequences indicated phases of settlement separated by periods of aridity. Radiocarbon dates placed early activity in the 8th and 7th millennia BCE, with later use occurring several thousand years afterward. In the Fezzan region of Libya, Settlements associated with paleolakes have been recorded near former wetlands along the Wadi al-Ajal. Survey work in the 20th century identified mounded areas containing domestic debris, storage pits, and structural traces. Excavations at selected sites revealed mud brick fragments, stone foundations, and compacted floor surfaces. These remains suggest semi-permanent dwellings rather than short-term camps. Lake Chad's former margins preserve extensive settlement evidence. Around the paleoshorelines of Mega Chad, researchers documented clusters of sites dating to the mid-Holocene. These include shell middens, fishing-related tools, and ceramic assemblages. Some sites extend for several hundred meters along ancient beach ridges. Their distribution corresponds closely with reconstructed water levels derived from geological studies. In northern Sudan, sites along the former Wadi Hawa corridor show a similar pattern. Habitation areas were located near residual pools and seasonal floodplains. Archaeological surveys conducted from the 1980s onward recorded stone circles, hearth features, and refuse deposits. Pottery styles and lithic typologies indicate long-term regional continuity, with gradual changes over time. Rock shelters near vanished lakes also served as residential spaces. In the Caucasus Mountains, shelters overlooking former wetlands contain thick cultural deposits. Excavations revealed layered sequences of ash, food remains, and domestic tools. Some shelters were used continuously for centuries, while others show episodic occupation. Differences appear to reflect changing water availability and mobility strategies. Housing structures in these environments were typically light and adaptable. Evidence from postholes, stone rings, and compacted surfaces suggests that many dwellings were built using wooden poles, grasses, and animal skins. Such materials rarely survive, leaving indirect traces. In some cases, impressions in sediment or patterns of stone placement indicate circular or oval floor plans. More substantial architecture appears in later phases, particularly in regions influenced by pastoral and early agricultural economies. In parts of southwestern Libya and southern Algeria, rectangular structures with stone footings have been recorded. These are often associated with storage features and enclosures. Radiocarbon dates and ceramic styles place many of these settlements in the late Holocene. Burial grounds are frequently located near habitation zones. At Takakuri, burials were placed close to living areas, sometimes beneath shelter floors. Similar practices are documented at other lakeside sites. Grave placement patterns suggest stable occupation over extended periods. The proximity of graves to dwellings indicates that these locations held long-term social significance. Activity areas within settlements can be identified through artifact distribution. Grinding stones and plant processing tools tend to cluster in specific zones. Fish processing residues and shell accumulations often appear near former water access points. Animal bone concentrations indicate butchering and food preparation areas. Spatial analysis allows researchers to reconstruct aspects of daily routines. Pottery provides important information about domestic life. Vessels found in lakeside settlements often show signs of repeated heating and repair. Soot residues and thermal cracking indicate cooking use. Decorative styles and manufacturing techniques vary by region and period. Comparative studies link these ceramics to broader cultural traditions across North Africa. Organic remains preserved in wetland sediments offer additional detail. In some former lake environments, plant fibers, seeds, and wooden tools have survived in waterlogged contexts. At sites in northern Chad and Sudan, preserved basket fragments and fishing implements have been recovered. These materials provide direct evidence of subsistence practices. Food remains reflect mixed economies. Early lakeside settlements often relied heavily on fishing and gathering. Later phases show increased evidence of herding and limited cultivation. Cattle, sheep, and goat bones become more common in mid to late Holocene deposits. Plant remains indicate the use of wild grasses and, in some areas, domesticated species. Mobility patterns can be inferred from site spacing and material sourcing. Many lakeside settlements are situated within short distances of each other, suggesting seasonal movement between related locations. Stone tools made from distant raw materials indicate long-range travel or exchange networks. Obsidian, chert, and quartzite sources have been traced across hundreds of kilometers, Water level fluctuations directly affected habitation stability. Sediment cores and shoreline studies show repeated cycles of expansion and contraction. During high water phases, settlements were concentrated on higher ground. As lakes shrank, new land became available, and habitation zones shifted inward. These adjustments are reflected in overlapping site distributions. Some settlements were abandoned permanently when water sources disappeared. Others were reused when conditions improved. At several locations in Niger and Libya, archaeological layers document multiple occupation episodes, separated by sterile sand layers. These gaps correspond with known arid intervals, identified in climate records. Preservation conditions vary widely. In stable shoreline environments, structures and activity surfaces can remain intact for millennia. In areas affected by dune migration or deflation, deposits are fragmented. Archaeologists must distinguish between original settlement patterns and later disturbance. This requires detailed sediment analysis and careful excavation. Survey strategies are adapted to these challenges. Teams often combine pedestrian survey with coring and geophysical methods. Ground-penetrating radar has been tested in some former lake basins to detect buried features. Although results are mixed in sandy environments, localized successes have been reported. Documentation emphasizes precise spatial recording. Site maps include elevation profiles, artifact densities, and sediment characteristics. Geographic information systems are used to integrate archaeological data with hydrological and geomorphological models. This allows researchers to place individual settlements within broader environmental frameworks. Comparative studies across regions reveal both shared and local patterns. Lakeside habitation in the Western Sahara differs in detail from that in the Nile-adjacent zones, yet both show consistent reliance on water margins. Architectural forms, subsistence strategies, and material culture reflect adaptation to similar constraints in different ecological settings. Interpretation remains cautious. Not all material near paleolakes represents permanent settlement. Some locations functioned as seasonal camps, processing stations, or meeting points. Distinguishing these uses depends on artifact diversity, feature density, and stratigraphic continuity. The archaeological record of vanished shores consists of scattered but recurring traces. Dwellings, hearths, graves, and refuse deposits mark places where people lived in close relation to water. Their study relies on careful correlation between environmental data and material evidence. Each documented site contributes a small segment to an extensive regional pattern. Routes between water and stone. Movement across the Sahara has long depended on the distribution of water sources and stable ground surfaces. Archaeological and geological surveys show that travel routes frequently followed chains of lakes, springs, and seasonal pools, connected by stretches of gravel, plain, or rocky plateau. These corridors allowed people to move between resource zones while minimizing exposure to deep sand and waterless terrain. Early mapping of desert routes began with colonial-era expeditions. In the late 19th and early 20th centuries, French and British surveyors recorded caravan paths and well locations in Algeria, Niger, and Sudan. These records, preserved in military and administrative archives, often correspond closely with routes later identified through archaeological fieldwork. Many of these paths followed older alignments that had existed long before historical documentation. In the central Sahara, the Tassili Naaja and Ahaga plateaus form major topographic anchors. Routes linking these uplands to surrounding basins have been reconstructed using satellite imagery and ground survey. Stone alignments, cairns, and compacted track surfaces appear at regular intervals along these corridors. In some areas, repeated foot traffic over centuries produced shallow depressions visible in low-angle light. Water availability shaped route spacing. Studies in eastern Libya and western Egypt show that wells and springs were often separated by distances that matched a day's travel on foot or with livestock. Archaeological surveys near the Kufra and Dakhla oases documented intermediate stopping points marked by hearths, broken pottery, and animal bone fragments. These sites suggest routine overnight use rather than permanent settlement. Rock shelters also served as temporary stations. Along the margins of former lakes and river valleys, shelters provided shade and protection for travelers. Excavations in the Tadrat-Akakas region revealed thin occupation layers containing mixed artifact types. These deposits are interpreted as short-term use by mobile groups passing through rather than resident communities. Stone tool sourcing provides direct evidence of long-distance movement. Geochemical analysis of obsidian artifacts from sites in Sudan and Chad has traced material back to volcanic sources in Ethiopia and Eritrea. Similarly, distinctive chert varieties found in Niger have been linked to outcrops in southern Algeria. These connections indicate transport or exchange over distances of several hundred kilometers. Grinding stones and heavy implements offer complementary information. Such tools are rarely carried long distances unless necessary. Their presence at temporary camps suggests repeated visits and established routes. In some corridors, clusters of worn grinding stones mark places where travelers processed gathered plants or prepared stored grain. Animal remains indicate the role of herding in route use. Cattle, sheep, and goat bones appear at many waypoints dating to the mid and late Holocene. These findings align with ethnographic and historical accounts of transhumance, in which herders moved seasonally between pastures and water sources. Archaeological evidence suggests that similar practices operated in earlier periods. Rock art sometimes records movement indirectly. In parts of Libya and Algeria, painted scenes depict lines of cattle and groups of people traveling through open landscapes. While not precise maps, these images correspond broadly with known corridors between water sources. Researchers caution that such representations are symbolic, yet they reinforce other lines of evidence. In the Fezzan region, fortified sites and small settlements appear at strategic junctions of routes. Excavations near Garama documented storage facilities and defensive walls positioned near converging paths. These locations likely controlled access to water and agricultural zones. Material remains suggest interaction between mobile groups and more sedentary communities. Desert pavements, composed of tightly packed stones, provided relatively stable walking surfaces. Routes often followed these pavements rather than loose dunes. Remote sensing studies in Mauritania and Mali show linear patterns aligned with such surfaces. Field verification confirmed that these corridors contained scattered artifacts and compacted sediments. Salt flats also functioned as travel zones under certain conditions. During dry periods, their hardened surfaces allowed rapid movement. Surveys in Tunisia and southern Libya identified artifact scatters along former playa margins. These areas appear to have been used seasonally, depending on surface moisture and stability. The identification of ancient paths relies on cumulative observation. Single tracks are rarely continuous over long distances. Instead, researchers piece together segments using topography, artifact distribution, and historical data. Geographic information systems integrate these elements to model probable corridors between known sites. Ground-penetrating radar and shallow coring have been used experimentally to detect compacted track layers beneath sand. Results from test areas in Egypt's western desert indicate that repeated trampling can produce subtle density contrasts. These features are difficult to trace over large areas but confirm that some routes leave physical traces below the surface. Weather events periodically alter route visibility. Wind can erase surface tracks within days, while rare rainfall can harden sediments and preserve impressions temporarily. Field notes from survey teams in Niger and Chad describe instances where camel and vehicle tracks remained visible for weeks after storms before being reburied. Human modification also played a role. In some corridors, stone markers were placed to guide travelers. Cairns, known locally by various names, appear on ridges and open plains. Radiocarbon dating of associated materials suggests that some were reused and rebuilt over long periods. Their locations often coincide with route intersections or difficult passages. Wells represent fixed anchors within mobile systems. Archaeological studies of ancient wells in Egypt's western desert document stone linings, wooden reinforcement, and sediment infill. Some wells show repeated cleaning episodes, indicating long-term use. Associated artifact layers record cycles of abandonment and reuse. Exchange networks are reflected in artifact assemblages along routes. Beads made from ostrich eggshell, marine shells, and imported stone appear at inland sites far from their sources. Compositional analysis links these objects to coastal and riverine regions. Their presence suggests regular movement of goods alongside people. Written sources from later periods provide partial confirmation. Medieval Arabic geographers described routes linking North African cities, oases, and sub-Saharan regions. Although focused on commercial travel, these texts often reference wells and landmarks that correspond with earlier archaeological corridors. The continuity suggests long-term stability in certain pathways. Not all routes were used continuously. Climatic shifts, altered water availability, and vegetation cover. Some corridors fell out of use when intermediate sources dried. Others gained importance during wetter phases. Archaeological layers at waypoints often show episodic use rather than uninterrupted occupation. Route density varies by region. In areas with clustered water sources, multiple parallel paths developed. In more arid zones, movement was concentrated into narrow corridors. This pattern is visible in satellite-based least-cost path models compared with field survey results. Interpretation remains cautious because absence of evidence does not imply absence of travel. Light use leaves minimal traces. Many journeys may have left no durable material record. Researchers therefore combine environmental modeling with archaeological data to estimate probable movement patterns. Modern infrastructure sometimes follows ancient corridors. Roads and pipelines in Libya, Algeria, and Egypt often align with routes that minimize sand cover and connect water sources. Engineering surveys occasionally note the presence of older tracks beneath modern surfaces. Documentation of routes emphasizes spatial accuracy. Survey teams record coordinates, elevation, surface type, and artifact density. Repeated visits help distinguish persistent features from temporary traces. Over time, these records build regional maps of movement. Travel corridors linked ecological zones. They connected lake basins with uplands, wetlands with pastures, and interior regions with coastal areas. These connections supported exchange, seasonal migration, and information flow. The material evidence reflects networks rather than isolated journeys. The archaeological record of routes is fragmented and dispersed. Individual hearths, tools, and markers gain meaning only when viewed collectively. Their study depends on broad survey coverage and careful integration of diverse data sources. Each identified corridor contributes to understanding how movement was organized in a changing desert landscape. Materials that traveled far from their sources, archaeological materials found in the Sahara, are often composed of substances that do not occur naturally at the sites where they are recovered. These materials include volcanic glass, marine shell, distinctive stone types, and mineral pigments. Their presence reflects movement across large areas and provides measurable evidence of connections between distant regions. One of the most frequently studied transported materials is obsidian. Obsidian forms only in volcanic environments and has limited geological distribution. In North Africa, major sources are located in the Ethiopian highlands, the Afar region, and parts of the East African Rift system. Yet obsidian artifacts have been documented at sites in Sudan, Chad, and southern Egypt. Geochemical analysis conducted since the 1970s has linked many of these artifacts to specific volcanic outcrops, hundreds or even thousands of kilometers away. Early sourcing studies relied on visual inspection and basic chemical tests. Later work introduced techniques such as X-ray fluorescence and neutron activation analysis. These methods allow researchers to measure trace elements and compare them with reference samples from known sources. In studies conducted at Wadi Howa sites, obsidian flakes were matched to Ethiopian sources with high confidence, demonstrating long-distance transfer during the early and middle Holocene. Chert and flint also show patterns of movement. Although these materials are widespread, many varieties have distinctive color, texture, and fossil content. Surveys in Niger and southern Algeria have identified chert artifacts whose geological origin lies far from their find locations. Petrographic analysis and comparison with known outcrops support these identifications. Some tool assemblages contain multiple chert types, indicating repeated contact with different source areas. Quartzite provides another example. In parts of Libya and Chad, quartzite tools appear in environments where suitable raw material is absent. Geological mapping shows that the nearest sources may lie more than 100 kilometers away. Transport of heavy stone suggests planned movement and repeated use of established corridors. Wear patterns on these tools indicate long-term use rather than casual discard. Marine shell, is among the clearest indicators of long-distance exchange. Shells from the Red Sea and Mediterranean have been recovered at inland sites deep within the Sahara. These include species such as Conus, Cypraea, and Nassarius. Many were modified into beads or pendants. Radiocarbon dating and stratigraphic analysis place some of these objects in early Holocene contexts. At Nabta Playa and other sites in southern Egypt, Red Sea shells were incorporated into burial assemblages. Similar finds appear at sites in northern Sudan and western Libya. Their distribution follows known movement corridors rather than direct straight-line distances. This pattern suggests staged transfer through intermediate communities. Ostrich eggshell beads form another widely distributed category. Ostriches inhabit semi-arid and savanna regions rather than deep desert. Eggshell beads found in central Saharan sites indicate either direct travel to ostrich habitats or exchange with groups living closer to those environments. Microscopic analysis of bead manufacture shows consistent techniques across wide areas, supporting the idea of shared production traditions. Mineral pigments were also transported. Red ochre, composed primarily of iron oxide, appears in many burial and habitation contexts. While some deposits occur locally, others are distant from known sources. Geochemical fingerprinting has been used in limited cases to trace ochre to specific geological formations. In the Caucasus region, certain pigment samples correspond to outcrops located several days' travel from the sites where they were used. Green minerals, such as malachite and chrysocolla, appear occasionally in late Holocene contexts. These copper-bearing minerals occur in restricted geological zones. Beads and fragments made from them have been found at sites in southern Libya and Niger. Their presence indicates access to mining areas or to exchange networks linked to them. Pottery raw materials also reveal movement. Clay sources differ in mineral composition and microfossil content. Petrographic thin section analysis allows identification of non-local vessels. Studies in the Lake Chad region have documented pottery imported from distant floodplains. These vessels often appear in specialized contexts, suggesting selective rather than routine transport. Glass artifacts from later periods provide additional evidence. In Roman and early Islamic contexts, glass beads and fragments appear at Saharan sites far from production centers. Chemical analysis links some of these items to workshops in Egypt and the Eastern Mediterranean. Their arrival reflects established trade routes that built upon earlier movement systems. Methods for identifying transported materials have expanded over time. In addition to geochemical and petrographic techniques, isotopic analysis is used to study strontium, lead, and oxygen signatures. These isotopes reflect geological and environmental conditions at source locations. When applied to stone, shell, or bone artifacts, they can indicate geographic origin within defined ranges. Databases of reference materials are essential to this work. Geological surveys and museum collections provide comparative samples. International collaborations have developed regional libraries of obsidian, chert, and mineral signatures. These databases allow researchers to test new finds against established profiles. Transport does not necessarily imply direct travel between source and destination. Many materials likely move through multiple hands. Exchange may have occurred at seasonal gatherings, shared pastures, or market-like settings near water sources. Archaeological evidence rarely preserves the details of these interactions. Instead, it records the final placement of objects within deposits. The quantities of transported materials vary by site and period. Some locations contain only a few exotic items, while others show substantial concentrations. High-density occurrences often coincide with major nodes in movement networks, such as oases, river corridors, or upland junctions. These nodes appear repeatedly in regional surveys. Functional analysis helps clarify why certain materials were moved. Obsidian and high-quality chert produce sharp, predictable cutting edges. Their transport reflects practical considerations. Shell and mineral beads, in contrast, served primarily decorative or symbolic roles. Their movement suggests social signaling and affiliation, as well as personal preference. Useware studies provide additional information. Microscopic examination of tool edges reveals patterns of cutting, scraping, and drilling. Some imported tools show extensive wear, indicating prolonged use after transport. Others appear unused, suggesting storage or ritual placement. Temporal patterns are evident in distribution data. During wetter periods, networks expanded and diversified. A wider range of materials appears at more sites. During arid phases, movement corridors contracted, and non-local materials become rarer. These shifts correspond with independently documented climate records. Regional differences are also visible. Eastern Saharan sites show stronger connections to the Nile Valley and Red Sea. Western Saharan sites are more closely linked to Sahelian and Atlantic zones. Central regions display mixed patterns. These variations reflect geography, hydrology, and long-term mobility traditions. Documentation of transported materials requires precise recording. Excavation reports include stratigraphic position, associated features, and spatial coordinates. Laboratory analyses are linked to these records to ensure contextual reliability. Without this integration, sourcing results lose interpretive value. Reanalysis of older collections continues to refine understanding. Many artifacts excavated decades ago were not originally subjected to modern analytical techniques. Recent projects have re-examined museum holdings from Niger, Libya, and Sudan. New sourcing data have altered previous assumptions about movement ranges and interaction zones. Not all transported materials are immediately visible. Small flakes, microbeads, and pigment residues can be overlooked without targeted sampling. Improved recovery methods, including fine sieving and chemical residue analysis, have increased detection rates in recent decades. Interpretation remains limited by sampling gaps. Large areas of the Sahara remain poorly surveyed. Some source regions are inadequately characterized. As a result, some materials cannot yet be matched confidently to origins. Ongoing geological and archaeological mapping continues to address these limitations. The movement of materials across the Sahara represents cumulative decisions made over many generations. Each transported object reflects a sequence of travel, exchange, and use. When examined collectively, these objects form distribution patterns that outline long-distance connections within an otherwise fragmented landscape. The study of transported materials relies on careful measurement rather than narrative reconstruction. Analytical results provide ranges, probabilities, and correlations. These data are combined with environmental and settlement information to situate artifacts within broader regional systems. The resulting picture remains provisional and subject to revision, signs of organization without written records. Across the Sahara, archaeological evidence shows recurring patterns in settlement layout, construction practices, and material production that indicate coordinated behavior. These patterns appear in contexts where no written records exist. Interpretation depends on spatial analysis, stratigraphy, and comparison across multiple sites and regions. One indicator of organization is the repeated arrangement of dwellings and activity areas. At several former lakeside settlements in Niger and Sudan, excavations revealed clusters of structures arranged around open spaces. These open areas often contain hearths, refuse deposits, and grinding stones. Their consistent placement suggests shared conventions about where certain activities should occur. Similar spatial arrangements appear at sites separated by hundreds of kilometers. In the Fezzan region, survey and excavation documented small settlements with regular spacing between houses and storage features. Stone foundations and compacted floors are often aligned along similar orientations. These alignments correspond to prevailing wind directions and drainage patterns. Such consistency implies planning informed by environmental knowledge and shared building practices. Enclosures provide further evidence of coordination. Stone or earth-built corrals have been recorded near pastoral sites in Libya, Chad, and southern Algeria. These structures vary in size but often follow similar circular or oval designs. Their construction requires collective labor and maintenance. Radiocarbon dates indicate that some were used repeatedly over long periods, suggesting stable social arrangements. Monumental or semi-monumental features are present in several regions. At Nabta Playa in southern Egypt, stone alignments and circles were documented in the 1970s and 1980s. These features consist of upright slabs and arranged blocks placed on former lake margins. Geological and archaeological studies date some of them to the late Neolithic period. Their construction required coordinated effort and knowledge of local stone sources. Comparable features appear in parts of western Libya and northern Niger, where stone rows and platforms have been mapped. Although smaller in scale, they display standardized forms. Excavation around these structures sometimes reveals associated hearths, pottery, and animal remains. These associations indicate that the features were integrated into everyday or seasonal activities. Burial practices also reflect organized behavior. Cemeteries near habitation areas often show consistent body positioning, orientation, and grave construction. At Gobero, burials were arranged in defined zones, with repeated placement patterns over time. Similar regularity is documented at Takakuri and other sites. Such patterns imply shared norms governing mortuary behavior. Grave goods provide additional information. Certain object types appear repeatedly in burials of similar date and location. Shell beads, ochre, and specific pottery forms are often associated with particular age or sex categories. Statistical analysis of burial assemblages supports the interpretation of structured social roles, although variations occur between regions. Standardization in tool production represents another indicator. Lithic assemblages from multiple Saharan sites display consistent core preparation methods and flaking techniques. In the Akakas region, blade and bladelet production follows similar sequences across different settlements. Experimental studies and refitting analyses show that these methods were learned and transmitted within communities. Pottery production shows comparable regularity. Vessel shapes, rim forms, and decorative motifs tend to cluster by region and period. In the Lake Chad Basin, ceramic traditions persist for centuries with gradual modification. Petrographic studies indicate that potters selected and prepared clays in similar ways. Measurement and proportion appear in architectural remains. Storage pits and silos at some settlements have standardized dimensions. Their capacities fall within narrow ranges. This regularity implies planned storage practices and possibly shared expectations about resource allocation. In pastoral contexts, enclosure sizes also display limited variation. Evidence of coordinated labor emerges in construction projects. Digging wells, building foggara channels, and clearing agricultural plots require sustained collective effort. In the Fezzan, underground water tunnels extend for hundreds of meters. Excavation and maintenance would have involved organized work groups and scheduling. Sediment infill patterns indicate periodic cleaning and repair. Distribution of specialized activity areas further reflects organization. At several sites, tool-making debris is concentrated in specific zones. Food processing remains clustered elsewhere. These spatial separations are consistent across occupation phases. They suggest agreed divisions of space within settlements. Exchange networks also imply coordination. The regular appearance of non-local materials at certain sites indicates stable participation in wider systems. Some locations functioned as recurrent exchange nodes. Artifact densities and diversity at these nodes exceed those of surrounding sites. This pattern points to recognized gathering places and negotiated interactions. Seasonal aggregation sites provide additional insight. In parts of Sudan and Niger, large sites with diverse material assemblages appear to have been occupied periodically by multiple groups. These sites contain unusually high concentrations of pottery styles and raw material types. Such diversity implies temporary convergence of communities with different regional affiliations. Rock art may record aspects of social organization. Certain motifs recur over wide areas and long periods. These include standardized representations of cattle, human figures, and geometric forms. Stylistic analysis suggests shared symbolic systems. While interpretation remains cautious, the consistency implies collective frameworks for visual expression. Animal management practices also show structured patterns. Herd compositions inferred from bone assemblages display consistent age and sex profiles. These profiles correspond to managed breeding and slaughter strategies. Similar patterns appear across multiple sites within the same region, indicating shared pastoral knowledge. Evidence of conflict management and boundary marking is limited but present. Some sites contain low walls, ditches, or restricted access points. These features are not extensive fortifications, but suggest control of movement or resources. Their placement near water sources supports interpretations of regulated access. decision-making structures are difficult to identify directly. However, the persistence of complex systems implies some form of leadership or consensus mechanisms. Maintenance of wells, tunnels, and enclosures requires coordination beyond household level. Archaeologists infer these arrangements from infrastructure scale and repair histories rather than from individual artifacts. Temporal continuity strengthens these interpretations. Even when sites are abandoned and later reoccupied, similar layouts and practices often reappear. This continuity suggests durable social traditions transmitted across generations. Documentation of organization relies on integrated datasets. Excavation plans, artifact inventories, radiocarbon sequences, and environmental records are combined. Geographic information systems allow comparison of spatial patterns across sites. Statistical methods are used to test whether observed regularities exceed random distribution. Limitations remain significant. Preservation bias affects visibility of structures and activity areas. Light architecture and organic materials rarely survive. Many organizational practices may have left no material trace. Interpretations, therefore, emphasize patterns repeated across independent datasets. Revaluation of older excavations continues to refine understanding. Early fieldwork often focused on artifact typology rather than spatial relationships. Recent projects have reanalyzed archival plans and collections. These studies have revealed previously unrecognized regularities in settlement organization. Comparative studies across regions highlight both shared and local features. Eastern Saharan communities show stronger ties to Nile Valley traditions. Western regions display closer links to Sahelian systems. Central areas combine elements of both. These differences reflect long-term environmental and cultural interactions. Organizational evidence also varies by economic base. Hunter-gatherer-fisher groups display different spatial patterns from pastoral communities. Mixed economies show hybrid arrangements. These variations demonstrate flexible adaptation rather than uniform models. Interpretation avoids attributing formal institutions without direct evidence. Terms such as chiefdom or state are rarely applied to these contexts. Instead, researchers describe observable coordination in labor, space, and production. This approach maintains consistency with available data. The cumulative record indicates that Saharan communities developed stable frameworks for cooperation. These frameworks operated without writing or centralized administration. They were embedded in daily routines, seasonal cycles, and shared technical knowledge. Their traces remain visible in settlement layouts, material standards, and infrastructure. Study of these patterns continues through regional surveys and targeted excavation. New sites and analytical methods regularly modify existing interpretations. Each documented example adds resolution to an incomplete record of social organization in arid environments. Evidence preserved in human remains. Human skeletal remains recovered from Saharan sites provide direct information about past populations. These remains are typically found in burial grounds near former lakes, wetlands, and habitation areas. Preservation varies depending on soil chemistry, moisture, and burial depth. In arid contexts with alkaline sediments, bones may remain relatively intact for thousands of years. In more acidic or unstable environments, only fragments survive. Systematic study of Saharan human remains began in the mid-20th century. Early excavations focused on basic description and measurement. Later projects incorporated radiocarbon dating, isotopic analysis, and microscopic examination. These methods allow researchers to reconstruct age, sex, diet, disease, and patterns of movement. At Gobero in Niger, more than 200 burials were documented during excavations led by Paul Sereno between 2005 and 2008. Osteological analysis identified two main occupation phases, separated by several centuries. The earlier group displayed tall stature and robust limb bones, while the later group showed shorter average height and different cranial proportions. These differences correspond with broader environmental and cultural changes in the region. Burials at Takakori in Libya have been studied for both skeletal and genetic information. Excavations revealed well-preserved remains dating from the early to mid-Holocene. Osteological examination documented age distributions dominated by children and young adults. Stable isotope analysis of bone collagen indicated mixed diets based on fish, plants, and later domesticated animals. These results align with environmental evidence for fluctuating water availability. Dental remains provide important indicators of diet and health. Tooth wear patterns reflect the consumption of gritty foods and stone-ground plant material. Caries frequency varies by period and region. In early Holocene fishing communities, caries rates are generally low. In later pastoral contexts, slightly higher rates appear, possibly linked to increased consumption of starchy foods. Microscopic analysis of dental calculus has expanded dietary reconstruction. Studies conducted on remains from Sudan and Egypt's western desert identified trapped plant microfossils, starch grains, and pollen. These findings confirm the use of wild grasses, sedges, and, in some areas, domesticated cereals. Residues of milk proteins have also been detected in some samples, supporting evidence for early dairying. Bone chemistry reflects long-term dietary intake. Carbon and nitrogen isotope ratios distinguish between terrestrial and aquatic food sources, and between plant and animal protein. Analyses from Wadi Howa burials show elevated nitrogen values consistent with significant fish consumption during wetter phases. Later, samples exhibit patterns associated with pastoral diets. Oxygen and strontium isotopes provide information about geographic origin and mobility. These isotopes reflect local water and geological conditions during childhood. When measured in tooth enamel, they indicate where an individual grew up. Studies in southern Egypt and northern Sudan have identified individuals whose isotope signatures differ from local baselines. These findings suggest movement between regions during early life. Skeletal markers of physical activity reveal aspects of daily labor. Muscle attachment sites on bones become more pronounced with repeated use. In several Saharan populations, strong development of lower limb and shoulder muscles has been documented. These patterns are consistent with long-distance walking, herding, and carrying loads. Variation between individuals suggests differing activity roles within communities. Joint degeneration provides further information. Osteoarthritis appears in vertebrae, hips, and knees of some adults. Its distribution reflects repeated stress and age-related wear. At pastoral sites in Libya and Chad, spinal degeneration is relatively common, possibly linked to riding, load-bearing, and prolonged walking. Trauma evidence indicates accidents and interpersonal violence. Healed fractures of arms, ribs, and legs appear in many assemblages. Most are interpreted as accidental injuries related to falls, animal handling, or travel. Sharp force trauma is rare but documented in a limited number of cases. Interpretation remains cautious because preservation and sample size affect detection. Infectious disease leaves recognizable traces on bone in some cases. Tuberculosis, treponemal disease, and chronic respiratory infections can produce characteristic lesions. Evidence for tuberculosis-like changes has been reported from several Nile-adjacent and Saharan sites. However, diagnosis based solely on bone remains tentative without molecular confirmation. Parasitic infection can sometimes be inferred from skeletal markers and associated sediments. Studies of burial sediments in northern Sudan identified parasite eggs, indicating exposure to waterborne and soil-based pathogens. These findings are consistent with wetland living conditions during humid periods. Child growth patterns provide insight into nutrition and stress. Measurements of long bone length and dental development indicate episodes of growth disruption in some populations. Enamel hypoplasia, visible as lines or pits on teeth, reflects periods of physiological stress during childhood. Such markers are present at varying frequencies across sites, suggesting regional differences in food security and disease exposure. Sex-based differences appear in skeletal assemblages. Males often show greater muscle development and higher rates of certain injuries. Females sometimes exhibit skeletal changes related to childbirth and repetitive domestic activities. These patterns are consistent with division of labor, inferred from settlement and artifact data. Burial position and treatment affect preservation and interpretation. Some Saharan burials are tightly flexed, others extended. Wrapping materials and mats have been documented in waterlogged contexts. At certain sites, bodies were placed on prepared surfaces or in shallow pits lined with stones. These practices influence bone orientation and post-depositional movement. Genetic analysis has expanded knowledge of population history. Ancient DNA has been successfully extracted from some Saharan remains, particularly from well-preserved sites in Libya and Egypt. Studies published in the 2010s identified genetic links between early Saharan populations and both sub-Saharan and Near Eastern groups. Mitochondrial DNA and Y chromosome markers show mixed ancestry patterns. Some lineages persist across multiple millennia, while others appear during specific periods. These changes correspond broadly with archaeological evidence for population movement and cultural exchange. Sampling remains limited, and interpretations are updated as new data become available. Proteomic analysis offers additional possibilities. Analysis of ancient proteins preserved in bone and dental tissues can provide taxonomic and physiological information when DNA is degraded. Early applications in North African contexts have focused on identifying dietary proteins and pathogen markers. Ethical and legal frameworks guide research on human remains. Many Saharan countries regulate excavation, export, and analysis. Collaborative agreements between local authorities and international institutions define research protocols. Reburial and curation practices vary by region and project. Curation conditions affect long-term study potential. Remains stored in controlled environments remain suitable for future analysis. Older collections housed in variable conditions may suffer from contamination and deterioration. Recent projects emphasize improved storage and documentation standards. Interpretation integrates skeletal data with environmental and archaeological records. Health indicators are compared with climate proxies and settlement patterns. Mobility signals are evaluated alongside material sourcing data. This contextual approach reduces reliance on isolated observations. Sampling bias remains a major limitation. Burial grounds represent only a portion of past populations. Certain age groups and social categories may be underrepresented. Differential preservation further skews available samples. Researchers account for these factors when presenting demographic reconstructions. Reanalysis of existing collections continues to produce new findings. Advances in laboratory techniques allow older specimens to be studied in new ways. Projects in Sudan, Libya, and Egypt have revisited material excavated decades earlier, generating updated dietary and genetic data. Comparative studies across the Sahara reveal regional variation. Eastern sites show stronger Nile Valley influences in genetic and dietary profiles. Western and central regions display greater links to Sahelian populations. These patterns reflect geography and long-term mobility routes. Human remains also preserve evidence of cultural practices. Cranial modification, dental filing, and decorative toothwear have been documented at some sites. These modifications follow consistent patterns within specific regions and periods, indicating shared identity markers. The combined biological record reflects adaptation to shifting environments. Changes in diet, mobility, and health correspond with hydrological and settlement data. These relationships are established through cumulative analysis rather than individual cases. Research on Saharan human remains continues to expand as new sites are excavated and analytical methods improve. Each dataset contributes incremental detail to population history. The evidence remains incomplete and subject to revision as additional material becomes available. Climate records, written in sand and stone. Reconstructing past climate in the Sahara relies on physical records preserved in sediment, rock, and mineral deposits. These records accumulate gradually through wind, water, and chemical processes. Once formed, they retain layered structures that can be sampled, dated, and analyzed. Each archive reflects specific environmental conditions at the time of its formation. Dune systems represent one of the most visible climate indicators. Sand dunes form when wind transports and deposits loose sediment under dry conditions. Their shape, orientation, and internal layering reflect prevailing wind directions and sediment supply. In Mauritania, Mali, and Niger, longitudinal and Barchan dune fields have been studied using trenching and coring. These studies reveal alternating layers of coarse sand and finer material, corresponding to shifts in wind strength and vegetation cover. Optically stimulated luminescence dating is commonly applied to dune sediments. This method determines when mineral grains were last exposed to sunlight, Results from dune fields in southern Algeria and Libya indicate repeated phases of stabilization and reactivation over the past 20,000 years. Stabilized phases are associated with increased moisture and plant growth, while active phases reflect arid conditions. Lake sediments provide more continuous records. When lakes are present, fine particles, organic matter, and chemical precipitates settle in distinct layers. Over time, these layers accumulate into thick sequences. Cores extracted from former and existing lakes preserve these sequences in chronological order. Each layer reflects water depth, salinity, and surrounding vegetation. Lake Yoa, in northern Chad, is one of the most studied Saharan climate archives. Sediment cores collected in the 1990s and early 2000s extend back more than 6,000 years. Analyses of pollen, diatoms, and geochemical markers document gradual drying after the African humid period. Unlike many Saharan lakes, Yoa never dried completely, allowing uninterrupted deposition. In the Chad Basin, cores from Paleolake deposits record the rise and fall of Mega-Chad. Shoreline sediments and offshore muds show alternating freshwater and evaporitic phases. Radiocarbon dating of organic material and carbonate layers places major lake expansions between roughly 9,000 and 5,000 BCE. Later layers show increasing salinity and dust input. Smaller paleolakes in Libya and Egypt provide complementary records. Cores from the Kufra and Dakhla basins contain sequences of clay, silt, and gypsum. These materials indicate transitions between wet, shallow lake conditions and dry, evaporative environments. Isotopic analysis of carbonates in these layers reflects changes in rainfall source and intensity. Speleothems, such as stalagmites and flowstones, form in limestone caves, where water drips from ceilings and deposits minerals. Their growth depends on precipitation and soil activity above the cave. In Saharan regions with exposed carbonate formations, caves preserve long climate records. Uranium-thorium dating allows precise age determination. Caves in the Tibesti and Enedi massifs have yielded speleothem sequences spanning tens of thousands of years. Oxygen isotope ratios in these formations reflect changes in rainfall and temperature. Higher ratios generally correspond to drier conditions, while lower ratios indicate increased moisture. These records often align with lake and dune data. Marine sediments off the West African and Mediterranean coasts contain material transported from the Sahara by wind and rivers. Dust particles settle on the ocean floor and become incorporated into sediment layers. Cores extracted from the Atlantic near Mauritania and Senegal contain thick sequences of Saharan dust. Analysis of these marine cores shows variations in dust flux over time. Periods of high dust deposition correspond to arid phases with active dune systems. Lower dust levels indicate wetter conditions with more vegetation cover. These patterns have been documented in cores collected by international ocean drilling programs. Pollen preserved in lake and marine sediments provides information about past vegetation. Each plant species produces distinctive pollen grains. By identifying and counting these grains in sediment layers, researchers reconstruct changes in plant communities. In Saharan records, pollen data document transitions from grassland and savanna to desert vegetation. Diatoms, microscopic algae with silica shells, are sensitive to water chemistry. Their species composition reflects salinity and nutrient levels. In lake cores from Chad, Sudan, and Libya, shifts in diatom assemblages mark changes in lake depth and evaporation rates. These indicators complement pollen and geochemical data. Isotopic studies extend beyond carbon and oxygen. Hydrogen isotopes in leaf waxes preserved in sediments reflect rainfall sources and intensity. Nitrogen isotopes provide information about nutrient cycles and vegetation density. These proxies are increasingly applied to Saharan archives. Alluvial deposits in former river valleys represent another climate record. Floodplain sediments accumulate during periods of active runoff. Inactive phases allow soil development and wind deposition. Stratigraphic studies in Wadi Hawa and other paleochannels reveal alternating fluvial and aeolian layers. These sequences document shifting rainfall patterns. Soil profiles buried beneath dunes also preserve climate information. These paleosols form during stable, vegetated periods. Radiocarbon dating of soil carbon establishes periods of landscape stability. Paleosols in Mali and Niger correspond to humid intervals identified in lake records. Travertine and tufa deposits formed by spring activity record groundwater flow and chemistry. These carbonate deposits accumulate where mineral-rich water emerges at the surface. In Libya and Chad, fossil spring mounds have been dated and analyzed. Their formation corresponds to periods of active aquifer recharge. Ice core records from polar regions are used for broader comparison. Although not local to the Sahara, they provide global climate context. Correlations between Saharan wet phases and high-latitude temperature changes have been established through statistical analysis. These comparisons help place regional records within global systems. Chronological control is essential for interpreting climate archives. Radiocarbon dating is applied to organic material such as plant remains and shells. Uranium series dating is used for speleothems. Luminescence dating is used for sands. Each method has limitations related to material availability and contamination. Age models integrate multiple dating results to produce continuous timelines. Statistical software is used to estimate uncertainties and interpolate between dated layers. These models are updated as new samples are analyzed. Revisions sometimes alter interpretations of climate timing and duration. Climate records show that changes were rarely uniform across the Sahara. Some regions became arid earlier than others. Mountain areas retained moisture longer than lowland basins. Coastal zones were influenced by ocean currents. As a result, humid and dry phases overlap rather than occurring simultaneously everywhere. Abrupt events are visible in several archives. Rapid drying episodes appear as sharp transitions in sediment composition and biological indicators. Some correspond to known global events, such as the 8.2 kiloyear cooling episode. Dust records indicate strong links between climate and atmospheric circulation. Changes in monsoon strength, trade winds, and pressure systems influence sediment transport. Modeling studies combine geological data with atmospheric simulations to test these relationships. Human activity can affect some climate proxies. Land use, herding, and burning alter vegetation cover and erosion rates. In late Holocene sediments, increased charcoal particles and disturbance indicators reflect anthropogenic influence. Researchers distinguish these signals from purely climatic effects through comparison across regions. Preservation varies among archives. Lake cores may be disturbed by bioturbation or erosion. Speleothems can be damaged by collapse or mineral dissolution. Dune records may be truncated by reworking. Interpretation requires careful assessment of these processes. Long-term monitoring continues at selected sites. Automated weather stations, sediment traps, and groundwater sensors provide modern reference data. These measurements help calibrate interpretations of past records. Comparisons between present conditions and ancient deposits improve reliability. Data integration is central to climate reconstruction. Individual records provide partial information. Combined datasets reveal broader patterns. Regional syntheses compile results from dozens of sites across North Africa. These syntheses are periodically updated as new studies are published. Uncertainty remains inherent in all reconstructions. Dating errors, sampling gaps, and proxy limitations affect precision. Researchers present results with confidence intervals and alternative interpretations. These practices reflect standard methodological caution. Climate archives form the environmental framework for interpreting settlement, movement, and adaptation. They provide independent records against which archaeological patterns are evaluated. Without these records, human activity would lack temporal and environmental context. Continued exploration and sampling expand the available dataset. New coring projects, cave surveys, and remote sensing analyses regularly add material. Advances in laboratory techniques increase sensitivity and resolution. Each improvement refines understanding of Saharan climate history. The accumulated record preserved in sand, stone, and sediment documents long-term environmental change. These records do not provide narratives. They offer sequences of physical measurements that must be interpreted through comparative analysis. Their value lies in their persistence and measurable structure. Periods of expansion and contraction. Archaeological survey data from the Sahara show that human presence fluctuated over time in response to environmental conditions. These fluctuations are reflected in changes in settlement density, site size, and geographic distribution. Periods of increased occupation alternate with intervals of reduced activity. These patterns are reconstructed through systematic field survey, radiocarbon dating, and spatial analysis. One of the clearest indicators of expansion is the clustering of sites along former lakes and river systems. During humid phases of the early and middle Holocene, surveys in Niger, Chad, and Sudan document dense concentrations of camps, villages, and activity areas. In some basins, dozens of sites appear within a few square kilometers. Artifact densities and feature counts suggest sustained use over several generations. At Gobero, stratigraphic and radiocarbon data show two major occupation phases, separated by a long gap. The earlier phase corresponds to a period of high lake levels and abundant aquatic resources. During this time, multiple burial clusters and habitation areas were active simultaneously. The later phase reflects a partial return of wetter conditions, but with fewer sites and smaller populations. In the Wadi Howa region, settlement patterns exhibit similar oscillations. Surveys conducted in the late 20th century recorded dense site networks dating to the early Holocene. These networks thin out markedly after approximately 5000 BCE. Later occupation is limited to scattered pastoral camps and seasonal stations. These changes correspond with declining river flow and shrinking wetlands. Expansion phases are also evident in the Fezzan Basin of Libya. Archaeological mapping shows widespread settlement along the Wadi al-Ajal during wetter periods. Small villages, agricultural plots, and burial grounds appear at regular intervals. As aridity increased, many of these sites were abandoned. Later occupation concentrated around permanent groundwater sources and oases. Settlement size provides another measure of demographic change. During favorable climatic intervals, sites tend to be larger and more complex. Excavated areas reveal multiple dwellings, storage features, and activity zones. In less favorable periods, sites are smaller, with limited structural remains and fewer artifact types. These differences reflect shifts in population size and economic organization. Radiocarbon databases allow regional comparisons of occupation intensity. By compiling hundreds of dates from different sites, researchers generate summed probability distributions. Peaks in these distributions correspond to periods of increased human activity. In the Central Sahara, major peaks occur between approximately 9000 and 6000 BCE, followed by gradual decline. Secondary peaks appear in the late Holocene, associated with pastoral and oasis-based systems. Site abandonment is a key feature of contraction phases. Excavations frequently document sterile sand layers separating occupation horizons. These layers represent periods when locations were unused. At several sites in Niger and Libya, abandonment intervals last centuries. Their timing aligns with independent climate proxies, indicating prolonged drought. Contraction does not always imply complete regional depopulation. Instead, it often involves spatial reorganization. As surface water disappeared, populations shifted toward areas with reliable groundwater, mountain runoff, or perennial springs. This process is visible in the increasing importance of oases such as Kufra, Dakhla, and Karga during later periods. Mobility patterns changed accordingly. During expansion phases, movement was more dispersed, with settlements spread across wide areas. During contraction phases, travel corridors became more concentrated. Archaeological surveys show increased use of specific routes, linking remaining water sources. Temporary camps cluster along these corridors. Material culture reflects these demographic shifts. During high-density periods, artifact assemblages are diverse and locally produced. Pottery styles, tool forms, and decorative objects show regional variation. During low-density periods, assemblages become more standardized and include higher proportions of non-local materials. This pattern suggests increased reliance on exchange networks during times of reduced local production. Burial evidence also reflects demographic change. Cemeteries associated with expansion phases contain numerous interments over short periods. In contraction phases, burial numbers declined and graves are more widely spaced in time. At Takakori, for example, burial frequency decreases after the onset of aridity, corresponding with reduced site use. Age profiles in burial assemblages provide additional information. Expansion phases often show balanced distributions of children, adults, and older individuals. Contraction phases sometimes show skewed profiles, with fewer young children represented. This pattern may reflect changes in fertility, migration, or burial practices, although interpretation remains cautious. Settlement relocation is another response to environmental stress. In several regions, later sites are situated on higher ground or closer to rock shelters. These locations offer access to residual moisture and protection from sand movement. Stratigraphic sequences sometimes show gradual upslope movement of habitation zones over time. Technological adaptation accompanies demographic shifts. During contraction phases, toolkits often emphasize portability and multifunctionality. Smaller, more versatile tools become common. Heavy equipment and large storage facilities decline. These changes are documented in lithic assemblages and architectural remains. Pastoral systems expanded during some contraction phases. As lakes dried, herding became a more reliable subsistence strategy than fishing or gathering. Survey data from Chad and Sudan show increased numbers of pastoral camps after major hydrological decline. These camps are widely spaced and often associated with grazing routes. Agricultural activity contracted in parallel. Evidence for cultivation near former lakes diminishes as water availability decreases. Abandoned field systems and irrigation features have been documented in parts of Libya and Egypt. Later, agriculture is concentrated in oasis environments, supported by deep aquifers. Exchange networks became more important during periods of reduced settlement density. Non-local materials appear more frequently in late Holocene assemblages. This pattern suggests that communities relied on broader networks to compensate for limited local resources. Nodes along major routes gained prominence as exchange centers. Population movement is inferred from combined isotopic and archaeological data. Studies of strontium and oxygen isotopes in human remains indicate increased mobility during arid phases. Individuals buried at certain sites show non-local signatures, suggesting migration from wetter regions. These findings align with settlement contraction patterns. Historical analogies provide limited contextual support. Medieval and early modern accounts describe fluctuations in caravan traffic and oasis populations linked to rainfall variability. While these sources postdate prehistoric periods, they illustrate similar relationships between climate and demographic stability. Not all contractions were gradual. Some records indicate relatively rapid decline. At several Paleolake sites, occupation ends abruptly within a few decades. Sediment and pollen data suggest sudden drying events. These episodes may have forced rapid relocation rather than slow adjustment. Expansion phases were not uniform across the Sahara. Some regions experienced peak occupation earlier than others. Mountain zones and areas influenced by residual monsoon rainfall retained favorable conditions longer. As a result, demographic peaks are staggered rather than synchronous. Survey coverage affects interpretation. Some apparent contractions may reflect limited fieldwork rather than true depopulation. Regions with sparse survey data show fewer sites by default. Researchers address this issue through sampling strategies and predictive modeling. Statistical models integrate environmental and archaeological variables. These models test correlations between rainfall proxies, vegetation indices, and site density. Results generally support a strong relationship between climate and population distribution, although local factors introduce variation. Reanalysis of legacy data continues to refine demographic reconstructions. Many early surveys lacked precise dating and spatial resolution. Recent projects have re-examined collections and field notes, improving chronological control. These efforts sometimes modify earlier interpretations of expansion and decline. Preservation bias also influences site counts. Sites in active dune fields are more likely to be buried or destroyed. Stable gravel plains preserve material more reliably. Correction factors are applied in regional syntheses to account for these differences. Periods of stability are visible between major expansion and contraction phases. During these intervals, settlement patterns remain relatively constant for several centuries. Artifact styles and architectural forms show gradual change rather than abrupt shifts. These phases reflect equilibrium between population and available resources. Interpretation emphasizes long-term trends rather than short-term events. Individual droughts or floods may affect local settlements without altering regional patterns. Demographic cycles emerge only when data are aggregated over large areas and long time spans. Population estimates remain approximate. Archaeologists infer numbers indirectly from site size, density, and occupation duration. These estimates carry wide margins of error. They are used primarily for comparative purposes rather than precise counts. The record of expansion and contraction reflects continuous adjustment to changing conditions. Communities reorganize settlement, mobility, and production systems in response to shifting water and vegetation. These adjustments are visible in the spatial and temporal distribution of sites. Understanding these cycles requires integrating survey results, dating programs, and environmental data. No single dataset is sufficient. Regional syntheses rely on collaborative research across multiple countries and institutions. Each newly documented site contributes to this broader picture. As survey coverage increases, patterns of demographic change become clearer. At the same time, new data introduce additional complexity, requiring ongoing revision. Periods of growth and decline are embedded within the material record. They appear as dense clusters and sparse gaps, large villages and isolated camps. These contrasts form one of the central features of Saharan archaeological history: contacts with neighboring regions. Archaeological evidence from the Sahara indicates sustained interaction with surrounding regions over several millennia. These interactions are documented through transported materials, shared technologies, and overlapping settlement patterns. Connections developed gradually and changed in form as environmental and social conditions shifted. They are reconstructed through comparative analysis of artifacts, architectural remains, and biological data. The Nile Valley represents one of the most significant zones of contact. From the early Holocene onward, similarities in pottery styles, stone tool technologies, and subsistence practices link Saharan sites with those along the Nile. Surveys in northern Sudan and southern Egypt document sites that combine desert and riverine traditions. These locations often contain mixed assemblages, including fishing equipment, pastoral tools, and imported ceramics. At Nabta Playa and surrounding areas, material culture shows clear connections with pre-dynastic Nile communities. Ceramic forms, decorative motifs, and stone vessel fragments correspond to types known from Upper Egypt. Radiocarbon dates place these interactions in the 5th and 4th millennia BCE. The distribution suggests movement of people and ideas, rather than isolated exchange events. Human skeletal evidence supports these connections. Genetic studies of remains from southern Egypt and northern Sudan reveal shared ancestry components between Saharan and Nile populations. Isotopic data indicate that some individuals buried in desert contexts spent part of their lives in riverine environments. These findings align with archaeological indicators of mobility. To the north, contact with Mediterranean coastal zones developed more strongly in later periods. Roman and early Islamic artifacts appear at Saharan sites from the 1st millennium BCE onward. Glass beads, amphora fragments, metal objects, and coins have been recovered from oases and caravan stations. Chemical analysis links many of these items to workshops in Egypt, Tunisia, and the eastern Mediterranean. Excavations in the Fezzan region document Roman period forts and settlements integrated into trans-Saharan routes. Sites such as Garama contain imported ceramics, glassware, and inscriptions. These materials indicate administrative and commercial links with coastal provinces. They also reflect the incorporation of desert corridors into imperial transport systems. Northwestern Sahara sites show interaction with Maghreb regions. Pottery traditions in southern Algeria and Mauritania display stylistic elements shared with coastal North Africa. Stone tool assemblages from late Holocene contexts show convergence in production techniques. These patterns suggest long-term regional integration. Southern connections link the Sahara with the Sahel and sub-Saharan Africa. Archaeological surveys in Niger, Chad, and Mali document artifact types associated with savanna and riverine cultures. These include distinctive pottery fabrics, grinding stones, and metalworking debris. Their presence reflects north-south movement along ecological gradients. The Lake Chad Basin functioned as a major interaction zone, Sites around its former margins contain materials from both desert and savanna regions. Ceramic assemblages combine Saharan and Sahelian traits. Faunal remains include species associated with wetter environments farther south. These mixed profiles indicate sustained contact and population movement. Metal objects provide further evidence of southern connections. Iron artifacts appear in central Saharan contexts during the late 1st millennium BCE and early 1st millennium CE. Metallurgical analysis links some of these items to production centers in West Africa. Their distribution follows known caravan and herding routes. Rock art records sometimes reflect external influences. In parts of Libya and Algeria, later paintings include horses, chariots, and weapon forms associated with Mediterranean and Near Eastern traditions. Stylistic analysis places these images in periods of increased contact. Their locations along travel corridors suggest transmission through mobile groups. Language history offers indirect support for interaction patterns. Comparative linguistics identifies links between Afroasiatic, Nilo-Saharan, and Niger-Congo language families in Saharan and surrounding regions. These relationships imply long-term contact and population mixing. Although linguistic reconstructions cannot be dated precisely, they correspond broadly with archaeological timelines. Caravan trade became increasingly important in the late Holocene. Historical sources describe routes connecting sub-Saharan Africa with North African ports. Archaeological remains confirm earlier foundations for these networks. Way stations, wells, and storage facilities appear along major corridors from at least the 1st millennium BCE. Salt, gold, ivory, and slaves were among the commodities moved through these systems in historical periods. Earlier exchanges likely involved livestock, stone, shells, and foodstuffs. Material evidence suggests continuity in route use even as traded goods changed. Technological transmission occurred alongside material exchange. Pottery-making techniques, herding practices, and architectural forms spread between regions. Comparative studies show gradual adoption and adaptation rather than abrupt replacement. Local traditions persisted while incorporating external elements. Agricultural practices illustrate this process. Limited cultivation in Saharan oases reflects techniques developed in the Nile Valley and Mediterranean zones. Irrigation methods, crop selection, and storage systems show parallels with neighboring regions. These similarities appear in archaeological and botanical records. Religious and symbolic practices also crossed regional boundaries. Burial customs, ornament styles, and ritual objects display shared features across wide areas. For example, the use of ochre, shell beads, and specific grave orientations appears in multiple regions. These parallels suggest communication of symbolic systems. Interaction intensity varied over time. During humid phases, movement was easier and more dispersed. During arid phases, contact became concentrated along a smaller number of corridors. Archaeological distributions reflect these shifts, with broader networks in wet periods and narrower ones in dry periods. Some regions functioned as intermediaries. Oases, such as Kufra, Dakhla, and Bilma, served as nodes connecting multiple zones. Artifact assemblages from these sites are especially diverse. Their composition reflects repeated interaction with both northern and southern partners. Not all contacts were symmetrical. Some regions acted primarily as sources, others as recipients. Obsidian moved mainly from eastern Africa toward the Sahara. Marine shells moved inland. Livestock and agricultural products moved in multiple directions. These asymmetries are visible in sourcing studies. Conflict and competition also shaped interactions, although evidence is limited. Fortified sites, weapon finds, and trauma on skeletal remains suggest occasional violence. However, most material indicators point toward sustained exchange rather than persistent hostility. Methodological integration is essential for studying these connections. Archaeologists combine typological comparison, geochemical sourcing, isotopic analysis, and spatial modeling. Each approach provides partial information. Together, they allow reconstruction of interaction networks with defined uncertainties. Reanalysis of museum collections has expanded knowledge of regional links. Objects excavated decades ago are now subjected to modern analytical techniques. These studies have identified previously unrecognized connections between distant areas. Survey gaps remain a major limitation. Large parts of the Sahara and surrounding zones are poorly documented. As new areas are studied, interaction models are revised. Some presumed routes are confirmed, while others are modified or abandoned. Comparative regional syntheses compile results from multiple countries and research traditions. These syntheses highlight long-term continuity in desert connectivity. They also emphasize regional variability shaped by geography and climate. Interaction patterns influence population history, technological development, and settlement organization. They contributed to cultural diversity within the Sahara. At the same time, they linked desert communities to broader continental systems. The material record shows that the Sahara was never fully isolated. Even during extreme aridity, corridors of contact persisted. These corridors supported movement of people, goods, and ideas across environmental boundaries. Understanding these connections requires attention to both local contexts and wide-scale patterns. Individual artifacts gain significance when placed within regional distributions. Settlement layouts and burial practices acquire meaning through comparison. Ongoing research continues to refine these interpretations. New excavation projects, expanded databases, and improved analytical methods add detail to existing models. Each addition modifies the overall picture of Saharan connectivity. The accumulated evidence documents long-term interaction between desert communities and their neighbors. These interactions were shaped by water availability, mobility strategies, and technological capacities. They were neither uniform nor static. Their study depends on sustained collaboration between institutions and disciplines. Geological, biological, and archaeological data are integrated to reconstruct complex networks. This integrative approach remains central to future research. The record of contact situates Saharan societies within continental history. It demonstrates participation in shared systems rather than isolation. These systems evolved over thousands of years, responding to environmental and social change. Records, limits, and ongoing investigation. Research on Saharan history depends on the continuous accumulation and evaluation of physical, biological, and environmental data. These records are produced through survey, excavation, laboratory analysis, and long-term monitoring. Each method contributes partial information. Interpretation relies on combining these sources into structured data sets that can be compared and revised. Field documentation forms the foundation of this work. Survey teams record site locations, elevations, surface conditions, and artifact distributions. Excavation projects generate stratigraphic profiles, feature plans, and sample inventories. These records are archived in national institutions and research centers. Standardized recording systems are used to allow comparison across projects and regions. Remote sensing has become increasingly central to documentation. Satellite imagery, aerial photography, and radar data provide regional scale perspectives. These tools identify paleochannels, dune systems, and potential settlement zones. Field verification remains necessary, but remote data guide, survey priorities, and reduce logistical uncertainty. Laboratory analysis expands the interpretive range of recovered material. Radiocarbon dating establishes chronological frameworks. Isotopic analysis reconstructs diet and mobility. Geochemical methods identify material sources. Microscopic and molecular techniques extract information from residues and degraded tissues. Each analytical result is linked to contextual data from excavation and survey. Databases integrate these results. Many research groups maintain digital repositories that include coordinates, photographs, dates, and analytical measurements. International initiatives compile regional datasets to support comparative studies. Access protocols vary, reflecting institutional policies and national regulations. Data sharing agreements govern collaborative projects. Chronological uncertainty remains a persistent limitation. Radiocarbon calibration curves are periodically updated. Reservoir effects and contamination complicate some samples. Luminescence dating carries uncertainties related to sediment exposure history. Age models incorporate these factors, but error ranges remain substantial. Spatial coverage is uneven. Large areas of the Sahara have not been systematically surveyed. Political instability, logistical constraints, and funding limitations restrict access. Some regions are represented by dense datasets, while others remain largely undocumented. This imbalance affects regional syntheses. Preservation bias further shapes the record. Organic materials survive only under specific conditions. Light architecture leaves limited traces. Wind and erosion remove or relocate deposits. As a result, some activities and settlement types are underrepresented. Researchers account for these biases through comparative analysis and modeling. Legacy collections present both opportunities and challenges. Many artifacts and samples were excavated decades ago, using methods that differ from current standards. Documentation quality varies. Recent projects have re-examined these materials using modern techniques. In some cases, new analyses have altered earlier interpretations. Legal and ethical frameworks regulate research activities. Permits are required for survey, excavation, and sampling. Export of materials is restricted or prohibited in many countries. Collaborative agreements emphasize local participation and capacity building. These frameworks influence project design and data availability. Training programs contribute to methodological continuity. Universities and research institutes in North Africa and abroad offer field schools and laboratory courses. These programs standardize techniques and promote data comparability. Graduates often participate in international projects, facilitating knowledge exchange. Technological change continues to affect research practices. High-resolution satellite imagery, portable spectrometers, and improved DNA sequencing platforms expand analytical capacity. These tools increase data volume and resolution. At the same time, they require specialized expertise and infrastructure. Interpretive models are revised as new data accumulate. Early reconstructions emphasized broad climatic phases and simple mobility patterns. Later studies introduced finer temporal resolution and regional differentiation. Current models incorporate complex interactions among environment, technology, and social organization. Unresolved questions remain. The timing and mechanisms of population movements are not fully established. The extent of early cultivation and its regional variability require further investigation. The social structures underlying large-scale coordination remain difficult to reconstruct. These gaps reflect both data limitations and methodological constraints. Comparative research strengthens interpretation. Saharan datasets are evaluated alongside records from the Nile Valley, the Sahel, and the Mediterranean. Similarities and differences are analyzed using standardized metrics. This approach situates desert communities within broader continental processes. Interdisciplinary collaboration is central to current research. Archaeologists, geologists, climatologists, biologists, and chemists contribute complementary expertise. Joint field projects and shared laboratories facilitate integration. Publications increasingly reflect multi-author, multi-institutional efforts. Funding structures influence research priorities. Large-scale projects often depend on international grants. These programs emphasize regional syntheses and high-impact methods. Smaller projects focus on targeted questions and local contexts. Both approaches contribute to cumulative knowledge. Public outreach and heritage management affect data preservation. Museums, visitor centers, and digital platforms disseminate research results. Site protection programs aim to limit damage from looting and development. Documentation produced for conservation purposes adds to research archives. Climate change introduces new variables. Shifting wind patterns, increased temperatures, and altered rainfall affect site stability. Some locations experience accelerated erosion. Others become more accessible as sand cover changes. Monitoring programs track these impacts. Digital archiving standards continue to evolve. Long-term data storage requires migration to new formats and platforms. Metadata documentation ensures future usability. International organizations promote best practices for archaeological data preservation. Language and publication practices shape accessibility. Research is published in multiple languages and journals. Some datasets remain unpublished or restricted. Efforts to produce open-access repositories aim to reduce these barriers. Statistical and computational methods play an increasing role. Bayesian modeling, network analysis, and agent-based simulations are applied to archaeological and environmental data. These tools test hypotheses about movement, interaction, and adaptation. Results depend on input quality and model assumptions. Educational materials derived from research influence public understanding. Textbooks, documentaries, and online resources synthesize findings. These presentations simplify complex data. Researchers review such materials to maintain accuracy. Long-term projects provide continuity. Repeated field seasons at the same locations generate detailed sequences. Examples include work at Gobero, Takakori, and Lake Yoa. These projects demonstrate the value of sustained investment. New survey initiatives continue to expand coverage. High-resolution imagery identifies previously unknown sites. Rapid assessment teams conduct preliminary documentation. Promising areas are selected for detailed study. Archival research complements fieldwork. Historical maps, expedition reports, and colonial records provide contextual information. Comparison with modern data reveals changes in landscape and site visibility. Institutional cooperation remains essential. Agreements between universities, museums, and government agencies define research frameworks. Shared training and infrastructure support long-term programs. These arrangements affect data continuity and accessibility. Interpretation emphasizes provisional conclusions. Findings are presented with uncertainty estimates and alternative explanations. Peer review and replication contribute to reliability. Contradictory results are addressed through further analysis rather than exclusion. The cumulative record of Saharan research reflects gradual refinement. Early broad models are replaced by more detailed regional frameworks. Each new dataset modifies existing interpretations. Knowledge develops through iterative comparison. Documentation practices aim to ensure that future researchers can re-examine current findings. Detailed field notes, digital records, and curated collections preserve analytical potential. This emphasis reflects recognition of long-term research value. Ongoing investigation depends on sustained collaboration, methodological transparency, and data preservation. Environmental change, technological development, and institutional priorities will continue to shape research trajectories. Adaptation to these factors remains necessary. The study of Saharan history remains an open process. Evidence is incomplete and unevenly distributed. Analytical techniques continue to advance. Interpretations remain subject to revision as new material becomes available. Research does not produce definitive narratives. It generates structured data sets and testable models. These outputs support comparative analysis across time and space. Their reliability depends on documentation quality and methodological rigor. Future work will extend existing records and address current gaps. Expanded survey coverage, improved dating resolution, and integrated biological analysis are expected to refine population and environmental reconstructions. These efforts will add detail rather than finality. The available evidence outlines long-term interaction between environment, movement, and organization. Its interpretation rests on cumulative measurement rather than isolated discovery. This approach defines current understanding of Saharan history. If this video made you question what you thought you knew, hit like and subscribe for more deep dives like this. New episodes are on the way, and you don't want to miss them. Drop your thoughts in the comments, share this with someone who loves hidden history, and stay tuned. Thanks for watching, and I'll see you in the next one.